So hello students, welcome back to our second video of our present chapter Work for Energy. In today's topic we will talk about the power concepts. So let's start with power. What is power? The simplest definition is rate of doing work. Rate of doing work. How much work you do in a certain amount of time is defined as power. So the formula of power is equals to work done by time. The formula for power is work done by time. Now from this part you can already see that power is an time dependent parameter. Hence power depends on time. Now power is a scalar quantity. Power is a scalar quantity. So let's take two cases. Case number one. If work is very high and time is very less, then power will increase. Case 2. Opposite. If work is very less and you have very much time, then the power required will be less. Okay? Go through the concept once. Clear your concept. Okay? So now let's go to the next thing, that is units of power. Now, for SI unit, power is equals to work by time, that is equals to joule per second, or in short, it is watt, W. So the SI unit of power is watt. Whereas, if you go to your CGS system, power is work by time, which is joule per second, and joule is arg per second. That is your CGS unit of work. Power. CGS unit of power, arg per second. So now, if power is equals to work by time, and we know that work equals to force into displacement, by time. So if I just write it down like this, force into displacement by time, then power becomes force into velocity. This is a very important formula Very important formula for the concept of power, to do the sums of power, that is force into velocity. Now, let's go with the difference of power and work. Difference between power and work. Work, power. Point number 1. Work done's formula is force into displacement, whereas power's formula is work done by time or force into velocity. So you can say that the product of work done is force into displacement, and the product of formula of power is product of force into velocity. Point number 2. This is time independent. Work is time independent. This does not depend on time, but this is time dependent. And the third can always be the unit. It's joule, and the unit is watt. Go through it once. Now, for the conversion of unit, I'll just do it over here. Conversion of unit, you can write 1 watt is equals to 10 to the power 7 erg per second. 1 watt is equals to 10 to the power 7 erg per second. Okay. Next. Mechanical unit of power. There is a unit which is often used in engineering devices or engineering appliances or in the engineering terms, which is known as the horsepower. Short form HP. The horsepower. So what is the conversion? Let's go directly. 1 horsepower is equals to 746 watt, or 1 horsepower is equals to 0.746 kilowatt. These are two mechanical units of work. Okay, the two mechanical units of work. And now, so going to the concepts of power, we can say that power depends on two parameters, that is work done and time. Power is directly proportional to work done, and power is inversely proportional to time. So, more the work, more power is required. Less work, less power is required. More the time, less power is required. Less the time, more power is required. The power's formula is work done by time, or you can say it's force into velocity. The unit of power is watt, or in watt in SI system, and in CGS system it's erg per second. Now, In this case, we have, let's say, a motor pump. Okay, a motor pump. Now, you have often heard about this, that pumps or mechanical devices are used for the term horsepower. So, a motor pump is generally rated as horsepower. What is horsepower? Horsepower is a mechanical device, and the mechanical unit of work that is used for power is horsepower. What is the unit change? 1 horsepower is 746 watt, and 1 horsepower is 0.746 kilowatt. Okay, again, the difference between work and power is force into displacement and force into velocity. Both work and power are scalar quantities. Power is time dependent, work is time independent. I'll just go through all the slides once more. Clear? If you want, you can add this kind of units also, like this. 1 kilowatt is equals to 1000 watt. These are general knowledge questions. Or 1 megawatt is 10 to the power 6 watt. Go through this once. So that is the complete power concept that you need to learn for your school exams. Hope you have understood everything from this video. Anyway, if you have any other doubts, please do comment. I'll try to clear them as soon as possible. Thank you everyone, and please like, share and subscribe. And for better concepts, please see my previous videos. Thank you everyone.